How has everyone's conference been? Yay, come on. It's great to get back together again, right? It's awesome to be back face-to-face. Europe in particular, I'm sort of including the UK in that, for apologies, but Europe in particular seems to have picked up fantastically well in the conference, in the face-to-face conferences. Not so much the rest of the world. US is still pretty poor, but Europe, I think we're all really enjoying getting back together and spending time learning from each other face-to-face again. I am going to talk about the magic of small things, microservices 10 years on. What I'm going to do is tell you some stories. I hope that's okay. I'm going to tell you some stories about what it was like working in IT back 15 years ago, before we were doing sort of this microservices thing. I'll talk a little bit about the giants, the shoulders of giants that I think microservices came from in large part. And then I'll talk a little bit about what's been happening since, and I'll finish up with a bit about the future. So that's the plan. Now, I said I'm going to tell a story, or series of stories. I think stories are important. My friend, old friend, thought worker, Simon Stewart, who will be featuring later, Simon, he used to talk about having a team shaman on the team. Every team should have a team shaman, right? And what he meant was, when you've got this big project, big complicated bits of technology, and someone new joins and they say, "Oh my God, why does this all look like this?" And the team shaman says, "Let's all gather around the campfire and I'll tell you the story of the build and how the build got the way it is." So I like this idea of having this team shaman, of having someone who can tell you the story of how things, from my perspective, got to the way they are. And I should point that out. This is from my perspective. I was at Siemens at the Future Architecture event last week, and I was talking about, obviously, I was talking about microservices and where they came from. And afterwards, Frank Bushman, who many of you, I'm sure, will know, the legendary, frankly, Frank Bushman, came over and he said, "James, it wasn't exactly then that they were invented. I heard about them at a NATO conference in like 2002 or something." But of course, Frank did. So what I'm going to talk about is my story, my origin story with microservices, and stuff that was on our mind back in sort of 2008, 9, 10, that sort of era. So the first thing, this clock hasn't started, incidentally. So it's fine, we'll just go over by 20 minutes, right? We'll just keep going. Don't start it. So the first thing I'll talk about is the landscape, the IT landscape that many of us found ourselves in. And many of us still do find ourselves in. Big, enterprisey software, stuff that was big and hard to change. This is actually known inside Thoughtworks as the rainbow diagram because of all the pretty colors that show you where data was smeared all over the Thoughtworks enterprise architecture back in about 2009. Talk about eating your own dog food. We weren't doing so much of that back then. But this is sort of representative of many big organizations. You had big sort of ERP systems, big finance systems, PeopleSoft, big homegrown legacy applications. Someone had got the message that we didn't like enterprise service buses. So they'd sort of, instead of getting a message bus, they'd created something called the middleware database, which was doing the same job, but it was a database. Excellent. But what was the characteristics of these pieces of software was that they were really difficult to change, difficult to scale. Lots of things like direct database to database access. We had, which essentially is like pouring concrete into your architecture, into your software architecture, makes things very difficult to change. A lot of software tooling was, again, big and enterprisey back then. Right, so we had things like IBM WebSphere, we had JBoss, WebFear, it's always known as in Thoughtworks actually. We had ClearCase in version control, right? We had Oracle, big Oracle databases, IIS, we would build a thing and install it into some application container and it would run it for us. And then we had, does anyone remember Mercury? Hands up if you remember Mercury. Test runner. We got some hands. So this was like one of the original record like test runs. You would record a user journey and then you would replay it as a test, essentially. Mercury. And it was awful to work with, You'd throw your software over the wall to testers, and they would record all these cases and run them overnight often. I said Simon Stewart would make an appearance. So Simon actually worked on a project called Selenium, which became WebDriver, which is now the W3C standard for, web testing, right? WebDriver. So Selenium is called Selenium because selenium is the cure for mercury poisoning. And that is true. So we've got all this big enterprisey stuff, right? Integration was super easy. Integration was, this is the WF Death Star set of specifications for basically SOAP, RPC, document-oriented SOAP. There's an ontology. There's a specification for the ontology to manage the ontologies of the integration standards in WS Star, right? This is big, complicated, hard stuff. And lots of other stuff was pretty controversial and or new. So things like the Spring Framework, which was a response to J2EE, that was pretty new back 2008, 2009. Things like Tomcat's pretty new. JUnit and test-driven development, behavior-driven development, that came about, or BDD came about in 2009. This is what you get if you ask an LLM of some description, a multimodal LLM, to give you an extreme programmer. That was all new. Trunk-based development, that was a crazy idea. We were using ClearCase. We had to have administrators running our version control systems. And AWS, again, very new. This is from a quote from a talk myself and Daniel Terhorst North did internally about 2009, where we said, wouldn't it be nice if we actually had a domain model? Because again, strings and ints and doubles, they were enough for everyone, right? No one wanted objects because objects were slow, right? We don't want to have lots of objects because if we have lots of objects, then garbage collection is going to slow everything down. So we just have strings and ints and doubles and get on with it. We wouldn't have address and name, like customer, product, order line. Why would we need any of those things? Need to understand the code that we were actually writing. And in terms of organizational structure, developer and operations, we were all the best of friends, right? We never had any separation. There was never a yawning crevasse of doom or chasm of doom between us all. We were the best of friends. So against this background, essentially is where microservices came from. Against the background of really big enterprise software that was hard to change. These big, expensive, often vendor-supplied application servers, big frameworks like J2EE and so on. But there was a bunch of people who were sort of at the right place at the right time. Clickety-click. Press the right button, James. At the right place at the right time. And there was this sort of moment, an opportunity to kind of cross the Rubicon. This is what happened when Julius Caesar marched on Rome and basically crossed the river, the Rubicon, with his army. And that was forbidden. You couldn't have the Roman legions in Rome. So the phrase crossing the Rubicon is an action that can't be taken back. It was the right time, the right place, and the Rubicon was going to be crossed. So as I said, this is my version of the microservices origin story. There's lots of other people in this room who I deeply, deeply respect who've got their own origin stories for microservices. I know Sarah does. Sarah talked very eloquently about the Financial Times and what they were doing back in 2012. Suzanne as well. Rob, I know you were working, many of the speakers, Chris, all working with service-oriented architectures amongst this group of people who I'll talk about. But in London in particular, back in 2010, 2008, actually from about 2001 to about 2010, there was this amazing explosion of ideas. Thoughtworks London started I work for Thoughtworks incidentally, if you can't see my branding. Thoughtworks London started in 2001, just after the dot-com crash, when there were a ton of people, contractors, suddenly out of work. So when we opened the London office, we essentially hired the entire London extreme programming community. That's actually true, that's what happened. The whole XP community started working for Thoughtworks, more or less. Some of them are on these slides. And some of the other publications are from friends of ours. So Michael Nygaard is a long-term ally of Thoughtworks, release it. This is Chris Reed. If you haven't come across Chris, he's one of the unsung heroes of the DevOps movement. So him and Patrick Dubois started the first DevOps days, where DevOps, the name, came from. We have Daniel Tilhorst North in the middle, who went on to create BDD, originate BDD. Sam Newman, who was my build monkey on the project I'll talk about in a minute, who wrote Building Microservices later. We had Gregor working for us back then, who wrote Enterprise Integration Patterns and is now one of the most, I think, insightful people we have working in the industry. But we also had Jim Weber and Ian Robinson, who wrote Rest in Practice. Martin wrote the foreword to the Blue Book. Jez and Dave were in London before they wrote Continuous Delivery. And this is Eric Donenberg, who's been my big mentor over the years, along with Rebecca, who spoke this morning. I was in Yash at CodeCamp 2 weeks ago. Michael Feathers was there. And he said, it's a really strange thing, James, because London at that time was just this incredible explosion of innovation, this incredible explosion of ideas, people fizzing off each other. It's almost like a sort of Xerox PARC or Palo Alto kind of effect. We've got a bunch of people trying to solve hard problems that hadn't been solved before, and then publishing their ideas rather than keeping them secret. I rolled on a couple of years to the Software Architecture Workshop in Castelbrando 2011. Now, I was invited to this. It's like a 3-day unconference that happens it used to happen once a year in different places in Europe. And I was invited to go along to be with a bunch of super interesting, smart people. And I said to Eric, my mentor, I said, Eric, why have they invited me to this event? There's all these really smart people. He said, well, he's German, he's in Hamburg. He said, well, you're pretty smart. You're pretty funny and you like a drink. That's literally what he said. So I went, okay, I'll go along. And Castelbrando was when the first time I actually had this personal idea. What if we're solving the wrong problem? What if instead of trying to solve the problem of maintaining and replacing big things, why don't we solve a different problem and start building smaller things? So this is Castelbrando. It's like a hotel just north of Venice. It's a tough life being a consultant sometimes. But hey. But the interesting thing about that, all those people I was talking about, some of them were there. Some other people you might recognize, you can't really see the photo in the lighting. But on the right-hand side there is Udi de Haan and Gregor. Stefan Tilkov was also there, as was Jimmy Nielsen from the domain-driven design world. So there was a whole bunch of people with interesting ideas coming together to talk about software architecture. It's about 30 people. And at that event, I had this idea about building smaller things. As I say, it's my origin story. Other people have got different origin stories to this, right? Then this happened to me. So Martin Fowler, would you buy a used car from Martin Fowler? I don't know. But Martin Fowler turned up at a project I was on, which was building a loyalty management platform to replace an existing one this loyalty company had. Loyalty management, you go to the supermarket, you buy your goods and you get some money off or whatever. It's an interesting domain. It's surprisingly interesting. It's basically building a retail bank from scratch. You have all the same capabilities that you would need to do retail banking and loyalty. Martin is very good at sniffing out where interesting things are going on and then turning up and offering you to buy a car. And he still does that. He still encourages us in Thoughtworks to contribute. He goes and visits projects and harvests interesting ideas. And actually, if anyone was in Rob Horn's talk earlier, it was Martin very much who encouraged that writing. So that project turned into a talk that I did in 2012 in QCon San Francisco called Microservices Java the Unix Way. And the subtitle was What I Did Last Summer, or I'm trying to look at that, how we designed and built a resource-oriented, event-driven system out of applications about 1,000 lines long. And this is the first time I'd started talking publicly. It was actually my first big public talk at a very big public event. This was the first time I started talking publicly about the set of ideas that Martin and I would go on to write about a couple of years later. So in that talk, I said, these things are small with a single responsibility. Right? Each application only does one thing, single responsibility principle, only one reason to change. And they should be small enough to fit in my head. I should understand everything about them, small enough to throw away rather than maintain. I said they should be located in different version control system roots, right? And at the time when building sort of big monolithic or relatively big monolithic applications, everything would be in the same version control root. So why, when we're building lots of these things, did I suggest splitting them up? The honest answer is because I'm too stupid to do anything else. Like, genuinely, I'm too stupid not to have different version control roots. I think every talk today has mentioned coupling, loose coupling of some description, and probably yesterday. This is about coupling for me, right? Different version control roots is about me seeing abstractions where I shouldn't see abstractions. There's an order here, and there's an order there. They look quite similar. Let's push them together, and we'll end up with a single order thing, and it's going to be massive. That's fine, right? And then maybe we'll extract it into a library, and then everything can use the domain library containing orders and customers and so on. I see abstractions where there are, or where I shouldn't see abstractions. But if you put all these different applications in different version control roots, then you don't hit that problem. You don't suffer that problem, right? Or at least it's harder to extract those abstractions and create, essentially compile and build time coupling. We also said containerless and installed as well-behaved Unix services. This is before Docker. This is before Kubernetes. They didn't come until 2015 and 16, I think, 14 and 16. At the time, we would build a thing, install it into Tomcat or JBoss or WebFear if you're unlucky, and it would run the thing for you and manage some stuff. But it was often slow, and we were looking at really fast build times. How can we get our software out through our continuous delivery pipelines fast, run our test cycles really fast, get fast feedback? Right, so by using things like embedded web servers, where you could just do Java minus jar, run the thing, the startup times are much, much quicker. And so we talked about containerless and installed as well-behaved Unix services. And then finally, provisioned automatically. Now, today, this is old news, right? You wouldn't think twice about maybe standing up another test environment as part of your build pipeline. Back then, these things were expensive. Having more than one UAT environment, it's going to cost you. We've got F5s. Can't buy another F5, all right? But this was the advent of the cloud and cloud native. So this was the advent of being able to create Phoenix environments. I want to run some tests. The build pipeline can create its own test environment for my tests. Again, pretty revolutionary at the time. I'm not claiming that no one else was doing this, but certainly this is what we were doing. And then I went on to say there's a consistent and reinforcing set of practices. A bit like extreme programming. It's like do all the architecture stuff and turn it all up to 11. Right? Do all the good stuff and turn it right up. So business capabilities composed of microservices that you rewrite that form this distributed bounded context, how they were deployed, et cetera, auto-scaling designed for failure. Now, I've already called out some of the names in the room who were also involved in this sort of stuff at the same time, but I think it's worth calling out in particular 4 people. So these 4 people in particular. So Stefan Tilkov, who I'm sure many of you in the room were probably great personal friends with. His ideas of self-contained systems, percolated through software architecture workshop and other events that he was talking about. Daniel Turhurst North at this point was working for investment banks. And believe it or not, traders and trading desks, that's what you do when you're on a trading desk. You build something called a microservice or something similar because you haven't got time to do anything else. If you want to take advantage of changing market conditions super fast, volatility super quickly, building lots of small things instead of maintaining a big thing is how you do it. Adrian Cockcroft was at Netflix. He was talking about fine-grained service-oriented architecture. And then Fred George, who had this idea of programmer anarchy and building nano services, 50 lines of code. All right. So all this was happening at the same time. But I don't think it was any coincidence. There's an interesting web of connections of people who know each other from going to events like this and sharing information, right? So I knew Stefan for a long time from various workshops and things and conferences. I worked with Daniel on many a project. Adrian is an old friend of Jim Weber, who wrote Rest in Practice, Chris Richardson is an old friend of our former CTO in Asia, Scott Shaw. Fred George is an ex-thought worker. Right? All these people knew each other and were sharing information. And so I'm going to take a moment to say, look, maybe that's a good thing, right? Maybe patents, yes, great patents, but actually openly sharing this stuff with each other, that's the way to actually make changes in the industry, get better at what we do. Anyway, after a little bit, Martin Fowler persuaded me to co-author this with him. So the original definition of microservices, where we set out the 9 characteristics that we believed led to the successful implementation of this style of software architecture. Now, as I say, in this, we quoted a number of other organizations that were doing the same thing. There were insurance startups. There was the Guardian newspaper group. There was the FT, although we didn't know that the Financial Times was doing it at the time, otherwise we would have quoted them. There were these banks that were doing it, and trading desks. And what we said was, this set of stuff, it seems like if you do this stuff together, you get good outcomes for a particular set of outcomes. Scaling teams, scaling the software, fast rate of change, fast flow, that sort of stuff. I said Martin persuaded me. He literally had to drag me to Boston. I went on a sleepover at Martin's house in Boston for a week, where we just wrote in his office. That's the only way he could get. It's like blood from a stone writing for me. You might know the Douglas Adams quote about deadlines. He said, "I love deadlines. I love the sound they make as they go whooshing past." And that's very much my approach to writing. I'm awful at it. But anyway, we did this thing, and 2 weeks later, we came up with this article where we described these components. So I'm now going to talk through some of these characteristics. I'll talk through some of these. I'm not going to give you everything that's happened with all of these characteristics over the intervening decade, but I am going to call out some highlights from back then and maybe from now. And the first is componentization via services. We said that a component, basically, is a unit of software that is independently replaceable and upgradable. That applies to modular monoliths, as we heard from the patents from Chris yesterday. We also then went on to say, something we should have said a lot more, that they are independently deployable. Right, and this comes to probably the biggest failure mode that I see most organizations have when they adopt microservices, is ending up with a distributed monolith, not being able to independently test and deploy or release services independently from one another. The problem is, it's because it's hard. Right, there's a whole set of other things you need to do in order to do that, right? I think Sam Newman said you need to be this tall to get on the ride, like the fairground ride. You need to be able to do continuous delivery. You need to understand things like contract-based testing, consumer-driven contracts, Postel's law, idempotency, how to create test doubles. All this stuff you have to learn, as well as distributed systems. This is not 101. This is a style of architecture to solve a specific set of problems. And having the capability to do all this stuff is super important. We'll go on from componentization via services to Alan Kay's definition of object-oriented programming, because it talks to kind of coupling and things. OOP to me means only messaging, local retention and protection, hiding of state processes, and the final bit, my bold, my highlight, my emphasis, extreme late binding of all the things, message passing. Right? Extreme late binding of all the things. If you remember back then, what we were tending to do was do things like create clients based on like SOAP RPC. We'd get a schema, get a WSDL schema, we'd generate a client, and then we'd use that client in our software to integrate with other services or other applications. Right? That led to really early binding. Right? Every time you change the other service, you have to rebuild your client libraries, redeploy your software. And when you're building monolithic software, there's lots of other places that might be affected by that. And there's lots of people who might be affected, other teams. That's why we sort of talked about things like different version control routes. Can we put tools in and put rules around those tools to allow us to avoid some of these obvious problems that we were seeing? Now, there are a few things that I get asked quite a lot, and a few problems I sort of see. One of these things is, consistently how big are microservices. Can't talk about componentization without saying how big. I genuinely still can't answer that question. We shouldn't have put micro in the name, because it wasn't really about the size. Probably down north's replaceable component architectures, or even fine-grained service-oriented architecture, or even self-contained systems were better names. Unfortunately, when Martin names something, it stays named. The other thing is nouns versus verbs. We've gone on to have this obsession with entity services, right? With user services, or with order services, or customer services, as opposed to the kind of the verb style of services. Create order as a service, not the entity itself. And those entities, basically, when you end up with entity services, you end up with a whole bunch of coupling. Talk to me afterwards. We can go through it. The next thing is organized around business capabilities. Now, Conway's Law has been talked about quite a lot at this event, and this is how I depicted Mel Conway in a series of talks I did many years ago about how I learnt to love Conway's Law. As like one of the Muppets from Statler and Waldorf, you know? He's sitting on the balcony laughing at us, because 50 years after he wrote the paper, we still haven't got it. Right. He's there doing that. We said, organize around business capabilities because they are the stable parts of your business. Right? Organize around things, and this is some examples of business capabilities. Organize around things like account management or order management. You'll always have to do that stuff as a retailer, say. How you do it changes, but you'll always have to do those things. You'll always have to do fulfillment. You might do it by drones in the future, but and at the moment it's trucks, but you'll always have to do fulfillment. So organize around the cohesive parts of your business. It'll help you build cohesive, decoupled software. A little while later, I got this email. Hey, James, I have recently come upon your presentations that go faster than your competitors and blah, blah, blah. No, I'm not sitting on the balcony laughing. I'm sitting at my computer learning from you. If you ever return to the Boston area, please let me know. All my best, Mel. There's a funny story. I was at another workshop. Mel Conway was actually there, and his wife Elizabeth came over and said, "Are you James Lewis?" I was like, "Oh my God, yeah, I am actually." And she said, "I want to say thank you for making all my grandchildren laugh," because they'd seen all the videos of me saying that Mel, their granddad, was a Muppet, and they thought that was hilarious. Yeah, true story. Decentralized data management. At the time, we talked about, hey, we can do polyglot persistence, we can use Neo4j if we need to, rather than just Oracle. Actually, it turned out that with this came a lot of additional effects. So it turns out distributed transactions are really, really hard to do. Right? Distributed transactions are really difficult. And we ended up, all of us, suddenly having to become an expert on CAP theorem. Now, that was definitely an unexpected side effect. Suddenly, we all had to know that you couldn't beat CAP theorem. We had to go for eventual consistency in general, not acid, go for base. And if you try and beat CAP theorem, there's all these checklists. You can't beat CAP theorem. Mike Nygaard wrote a talk about exploiting loopholes in CAP, where at the end he said, you can't. It's exciting. And then Google did a brilliant talk on Cloud Spanner. This is Cloud Spanner, where they said, we've beaten CAP theorem, sort of, because we're consistent and available, because our networks never go down, because we're Google. All right, okay, well, the rest of us who aren't Google. And then they went on to say, and that's because we bought all the atomic clocks. Again, not something most of us get to do. So we all had to become an expert suddenly on distributed systems, distributed transactions, CAP theorem, eventual consistency. Which leads me to a bit of advice, again, another failure mode. Favor bigger service boundaries over distributed transactions. If you're ever in a position where you're thinking about a transaction across two services, Starbucks doesn't use two-phase commit, as Gregor pointed out in the panel last night. Favor the bigger service. Combine things so you've got a single transaction. Next up, products, not projects. This coffee is quite good for conferences. Now, first time I went to a face-to-face conference after the pandemic, I made the joke on stage that there were two things I never thought I'd miss. Airports and conference coffee. Turns out I missed both. Weird. Now, products, not projects. We were some of the first, I think, to start talking about this. Right. The idea that we're not going to have these short-lived projects where a bunch of devs will do a thing, hand it over the fence, and then move on to the next thing. Rather than that, we're going to build these autonomous teams which are going to, over a period of time, manage the life cycle of the application, of the product that they're building. Building software that's never done, we talked about. And the interesting thing about product mode versus project mode is product mode and project mode is about how to finance software development fundamentally. So when we talk about building business capabilities and oriented around that, that's because they're stable, they're the sort of stable parts of the business. But when we talk about products over projects, what we're talking about is how we finance software delivery. Right? And this is often another failure mode I run into. The idea that we're going to just build a set of microservices, someone else will operate it, we'll move on to the next one. That was never the idea. The idea was you would build them, you would run them over a long period of time. Famously, Netflix talked about this, their API, they talked about rebuilding many, many times, right, in different languages as they learnt more, learning more about the product that you're building. Team Topologies has gone on to talk about this at length, as has Heidi Heflin's excellent dynamic reteaming, which is about how you can successfully move people around between teams in order to both provide them with, to build a better culture, to provide people with more enthusiasm, but also to kind of balance work out across teams and things. There's been a lot of work done on this over the years, and I suggest if you haven't read these books, take a look at it. But products over projects is still one of the, again, contentious things in lots of organizations, because it speaks to money, it speaks to how are we going to finance this stuff, how are we going to shift from CapEx to OpEx driven development, essentially. What happens when the software is maintained over a long period of time, or rebuilt and rebuilt and rebuilt? You can't really put that as part of, you can't really get any tax back or whatever it is, you kind of write it off over a period of time. So it's difficult to do. Next up, decentralized governance. We didn't really know what we were talking about, if I'm honest. We sort of had this vague idea about pushing responsibility down to teams and team autonomy, creating these autonomous teams. My favorite book on this, and if you haven't come across this book, as leaders in organizations, immediately buy this book. It's absolutely fantastic. Turn the Ship Around by L. David Marquette. It's about the story of how he took the worst performing boat in the US Pacific Fleet, submarine, and turned it into the best performing by every available metric in the whole of the US fleet, across all of it. And in that, he's got this lovely set of ideas about how you can push responsibility down in the most risky environment that you can possibly think of, right? The most risk-averse environment you can think of. And he says, don't move information to authority, move authority to the information, right? Get the people who know the most about the problems that they're trying to solve, give them enough information so that they can solve them themselves. Brilliant book. I won't go into it anymore, but it's fantastic. I mean, there's a whole bunch of stuff been done on this since. I'm going to call out some books. There's my colleague Andrew Harmon-Law's book, Facilitating Software Architecture, which has just been released. It's a different cover. There's the Software Architect Elevator. There's Team Topologies again. And my ex-colleague Rebecca Parsons, Building Evolutionary Architectures. In a talk I did, actually that of Java, the Unix Way talk, I had tip 10, make it easy to do the right thing and hard to do the wrong thing. And that really, again, speaks to this idea of decentralizing governance. How do you make it safe for organizations to, as Gregor said, stay on the paved path without hitting the guardrails, right? If you were in that talk last night, fantastic talk. Well, one way of doing that is platform engineering and building platforms. My colleague Evan Botcher wrote this paper on Martin Site's article, What I Talk About When I Talk About Platforms. We were pretty early in Thoughtworks talking about platform engineering. In fact, on our radar in Assess in 2017, we said organizations have tackled this challenge by creating platform engineering product teams. Product is the operative word there. I'm not sure if the industry was really listening, but then a little bit later we said, no, actually, applying product management to platform teams is really, really the way to go. Don't just build a platform and expect people to use it, right? Actually go out and do user research with your developers, actually find out what they need from the platform, and then maybe it'll be adopted. As opposed to, we're just going to go away for 3 years, build a big thing, and then complain that no one's using it. a little while later, we had to go even further and say, no, hold, like really don't build these really annoying platform teams that no one uses, right? These miscellaneous platform teams, we called it. We struggled quite hard with the wordsmithing. But the point about the platform team is to provide this self-service access to tooling, to software, sometimes to business capabilities. Right? But self-service is the key because that's the thing that makes you go faster. There's a lot more in team topologies and elsewhere. Next up, smart endpoints and dumb pipes. I refer you to my previous slide containing all the WS star specifications. Now, at the time, we were very into the kind of REST and RESTful integration. Right? So there's a brilliant talk called Justice Will Take Us, 1,000,000 Intricate Moves by Leonard Richardson of the Richardson maturity model fame. And in this, the million intricate moves is because we've backed ourselves into such a corner with all this heavyweight integration that it's going to take us 1,000,000 intricate moves to get out of it. But in that, he talks about why HTTP and RESTful architectures are so powerful for integration. He says they allow you to divide and conquer, take a big thing, break it up into small things using URIs. They allow you to reduce complexity by using the same protocol everywhere, in this case, HTTP. And they allow you to describe special behavior in specific ways using hypermedia. Now, I'm not sure what happened. I think I know what happened, actually, because event-driven architecture sort of took off. I'm not really sure what happened to all these good ideas that we had back then. Things like microformats. There was well-known, well-understood formats for most things that you might want to use. You could just use them. There was a schema. Everyone knew what an address was. What happened to domain application protocols? The idea that we're going to come up with a well-understood mechanism of communication that the entire organization can understand is simple. We can just do it in one way, like HTTP. And who can I blame for JSON? I'm really serious about this. JSON is terrible. Who can I blame for JSON? Because XML allowed you to do cool stuff. Like you could have hypermedia naturally. You could have things like forms and links. You could have schemas that you could use. You can kind of in JSON, but we lost all of that, and that's kind of annoying. Or we have to tunnel it through a bloody serialization framework. Now, it's not smart endpoints and dumb pipes, of course. We've moved on. We're using things like Kafka these days, RabbitMQ back then. Using things like Kafka. Gregor had this lovely talk from 2007, which I pulled a slide from. This is where he first starts talking about the matrix. All right, Matrix and Neo. And he says, the architect's view of distributed systems and event-driven and messaging is that they're loosely coupled, asynchronous, composable, etc. The developer's view is they're a bloody nightmare, right? They're really hard to understand, hard to reason about. Traceability is difficult. Yeah, it's kind of tricky, right? We've got this really powerful technology, event-driven architectures, messaging. But on the one hand, it gives us a nice set of properties. On the other hand, it can be really, really hard to work with. There's a fun quote from someone I knew, from a chief architect at a project I was on. And he said, when you or Sam are in the room, we can understand what you're talking about. But as soon as you leave the room, we can't understand it, basically. And it was an event-driven system. Then, of course, we ended up with another brilliant invention. Yeah, RPC. Let's just go back to RPC, shall we? Because RPC is a brilliant idea of just invoking methods across the wire without remembering the networks in the way. Again, Google has a specific set of requirements why they might want to use gRPC. Most of us don't. This is Martin Fowler's law of remoting. Lots of laws this week. Don't. Simply. Obviously, we've got a ton of stuff, ton of infrastructure now that we can use. We've got, all the cloud providers will give you, we'll get queuing services from them, notification systems. We can use, Kafka, we can use Lambdas, we can use all this sort of stuff. But with great integration power comes a high probability of messing it all up, frankly. Right? And again, Thoughtworks put on hold Lambda pinball on our radar, because we're seeing lots of organizations building tons and tons and tons of functions as a service, or I think Stefan used to say, building tons of database triggers in the cloud. I think that was his line. but not thinking about domains, not thinking about how these things should be organized. And you end up with this like amorphous mess, big ball of mud composed of functions running in the cloud. Next up, evolutionary design. So I think about evolutionary design in a particular way. I think about it as having options for the future. Gregor talked about this idea of buying options. Every line of code we write, every architecture decision we make closes or opens or creates options. If we're lucky, those options are in the money. Rebecca Parsons, again, along with Neil Ford and Pacquart and Pramod Sadalaj, they wrote Building Evolutionary Architectures to clear up some of the sort of fuzziness in this world. How can we build things like fitness functions that allow us to guide our architecture in a particular direction? It's, again, well worth reading about this. The thing is, these days, when we've got things like fitness functions, a lot of the things that we thought were hard to change have actually become much, much easier. In terms of evolutionary architecture, I've not even talked about architecture decision records, using things like RFCs internally, real options, guardrails, tools over rules, and how all this ties in again with platform evolution, using platforms to guide the evolution of the software that we're building. Infrastructure automation, we also had that in there. This is the CNCF landscape as of 3 weeks ago. None of that existed in 2012, none of it. It's pretty impressive, really. I mean, you've got to have an XKCD cartoon, haven't you? Let you read that while I have some coffee. We've built up all this stuff that does stuff. It's quite impressive. And also, we haven't even agreed on what infrastructure as code, or is it data, or is it from data is. Right? We've still got really poor abstractions around infrastructure and how we build, how we define our infrastructure in the cloud, for example. There is some stuff happening in the future. So we've got the future of DevOps automation, which is apparently a system initiative from the person who brought you Chef. We've also got Winglang, which is another language that's just been created to help with infrastructure automation. But it's still a bit of a mess. Now, design for failure. I talked about Martin's law of remoting. Don't. Because the thing with networks is they can fail. Mike Nygaard said every socket, process pipe, or remote procedure call can and will hang, even database calls. I like this from the Art of Unix programming. It's the rule of repair. Repair what you can, but when you must fail, fail noisily and as soon as possible. Blow up. Scream and shout at everyone and then blow up. Otherwise, stay silent. All right? Build systems that are resilient to failure, anti-fragile systems. Build systems that can stay up in the face of downstream failures, but that also, when they do need to, make sure they alert everyone. Chaos engineering wasn't a thing back in 2012. That's new. Turning stuff on and off in production just for laughs. Sounds like a great idea, doesn't it? But that took off. Observability. That's just the observability bit for CNCF, this bottom bit. That's just observability tools. I was at a startup once, and the CTO genuinely looked at me and said, James, our job in this workshop is to pick one from every single box in the Cloud Native Computing Foundation landscape, and then we'll integrate them all together, and then we're done. Didn't work out. I mean, the interesting thing here is that you've got some stuff happening like Observability 2.0, Charity Majors from Honeycomb. She's been writing about this. Is it time to change observability, change up what we're doing, use wide logs, canonical logs, and so on? And she's written about this quite extensively online, and there's a lot of talks about it. It's kind of interesting. Now, there have been some unexpected side effects over the years. Martin said microservices moves the accidental complexity to the infrastructure. This is what AWS referred to as undifferentiated heavy lifting back in 2011. But actually, what's happened now is we've moved this sort of undifferentiated heavy lifting has become undifferentiated essential complexity. We've taken all the stuff, when I say essential complexity, it's essential we do things like TLS termination. We've moved all that out to a set of tooling, service meshes, things like sidecars, Istio, etc. And obviously things like Kubernetes and Docker. Developer experience platforms, we didn't have those back then. Who cared what developer thinks? No one cared what developers think, just work hard. Type faster, goddammit, although all the stuff about developer productivity. It's happening again. Data mesh. This is the last bastion of the layered or tiered architecture being sort of taken down, stormed by, again, distributed system design. Building data products that are independent from one another rather than building big data warehouses or data lakes. Again, a paradigm shift. What do I wish we'd done differently? Like this is Daniel Tilsnor's quote. It's a spin on the Philip Greenspun's 10th law, right? Any sufficiently complicated microservices implementation contains an ad hoc, informally specified, bug-ridden implementation of half of Erlang. And there's something very true about that. Maybe we should have just used Erlang. So, to summarize, infrastructure as code is still a mess. We need to do better at that. We've still got single integration testing environments on the radar. Right? We're still building distributed monoliths and integrating them all together. Right? That's not what we meant, genuinely. You can take that as a quote. That really isn't what we meant. The name, we sucked with the name. It was never about size. It was about decoupling. It was about scaling teams. It was about organizations as much as anything else. But all we've concentrated on is how big they are. That's our bad. We missed. We didn't really talk about cloud native. We didn't really talk about how important continuous delivery was and how important being this tool was. And I think, again, that's kind of our bad, right? We missed out there. We kind of assumed everyone knew this stuff, and maybe everyone didn't. We also didn't talk enough about independent deployability, the ability to test things in isolation, deploy them on their own. We didn't talk enough about independent deployability. We didn't talk enough about independent deployability. So I promised the future. Are microservices the future? I've got 2 minutes left to run. Are microservices the future? We sort of said this in the article. We write this with cautious optimism, blah, blah, blah. It might be a worthwhile road to tread. Fun fact, they never made it to adopt on the Thoughtworks Technology Radar as a technique. It's too nuanced. The decision to use them is too nuanced. If you have the requirements, then build microservices. If you don't. It's as simple as that. But hey, we're all architects. We know that, don't we? However, if you look at the State of DevOps report, of which there are 2 different versions these days, amusingly. This is the one from Google. Where are we? Loosely coupled architecture leads to substantial increases in team performance, organizational performance, and operational performance. So there must be something in there somewhere. And apart from that, the future is robots. But we all knew that, didn't we? Yeah, thanks very much. And I'd like to finish, because I know there's a lot of his friends in the room, and including myself, with saying, yeah, thanks, Stefan. Cheers.